I'm killing the cache again, and I will ramp it up to 1,000 concurrent connections. That's quite a bit for this little guy. It takes a lot of water. You see that? Our load even goes down. We have computing time to spare here. Even though it's under this kind of fire. I have to confess something. Actually brought the wrong cable. One of my cables here, I wanted to use a shorter one, so I took one from the storage in the office, and I brought one which is not really good. With my setup at home, I managed to have these transactions at 1,200. 12,000, sorry, 12,000 transactions with this little guy with that setup. And the latency here with that it only gets around 6,000 is due to the cable. Must be due to the cable because the only part I changed in my setup. Okay, that's not bad. I like this part. I like this part. What's the problem with this kind of caching? It's just a 10-second cache, but it is a cache that's there 10 seconds. The problem is everything gets cached. Everything. Everything which is created by PHP gets cached. If it gets changed in the backend, it will take some time, even if it's just 10 seconds, to actually refresh on the server. Cache control headers, if they are there, are ignored. They are all ignored right now. We can go back, sorry. No, wrong one. Go back here. It here, ignore headers, cache control expires in set cookie. We ignoring all those headers. We don't take them into account when caching. And there's actually no easy way to purge the cache for a specific page. There is a methodology. Basically, the URL gets MD5 encoded or MD5 hashed. The cache key gets MD5 hashed. And that's the file name it uses to save the cache. That's what Nginx uses to save the cache. And you actually would have to calculate that hash and remove that file from the file system to actually manually purge the cache. When I say I purge the cache via my shell script, I'm just deleting everything which is under there. So no easy way to do that. That's a bit of a little of a problem. I mean, we are talking right now of a boring company website. If that would be a store, 10-second cache is deadly. You can't have 10 seconds of your shopping cart be cached somewhere. That's not possible. That won't work. If we could just compartmentalize different parts of our web page and deliver them based on their lifetime, that would be cool. Something like iframes or frames before. There we had a nice compartmentalization of the web page. Everything could be delivered differently. There is a technology for that. It's called SSI, server-side include. Who knows that? Who knows what SSI is? Who is old enough? Yeah. That's how we made web pages dynamic in 1990. That's the first part. That's the first thing the NCSA included for the problem. But I just want one file for my navigation and for my footer, and not have it copied all over my HTML files. What it does, it takes this statement this comment is written in the HTML content, and it will be passed by the server, by the web server, and replaced with the content of the file or URL it references. So I can have a static page with those include virtuals, and the web server will replace them, basically. Virtual means that you can take any kind of URL, that you can put there any kind of URL. And there's an extension for that in TYPO3. Of course, we would say first, TYPO3, send the cache headers. We want cache headers, that's good. And the extension is called InCache. It was developed by Nicole, and she made it for caching with Varnish, with the ESI tags, which are used as well by Cloudflare to make dynamic web pages, to offload the creation of web pages to different servers. And what the extension does, it takes every user int or non-cached part of the website and caches the configuration for that, puts it away, and will be and can be called by a page type. So we'll have a page type and a cache ID, and this page type will get that cached or non-cached content for you. The configuration is cached, not the content. So every content with user int which you put out there will be fetched dynamically, and it will be included with those include virtual links. Sorry, I should have asked that first. Are you all aware how the non-cached objects work inside TYPO3? Who knows? Who knows? Basically, TYPO3 renders the page, and every time it finds a non-cached object, it will put in a marker for that object. If you break the process, or if you stop the process, you can actually see them in the HTML content. And then after the page is created, it will cache the page, and then it will run through the page again and replace those markers with the uncached content. So basically, what this extension does is changing that behavior in that way that it doesn't replace the non-cached markers in the web page, but it adds those include virtual markers. So I want to use that. I'm changing my ignore headers. I only ignore cookies. I tell Nginx use server-side includes. The cache key hijinks here I do there is a problem with Nginx that sub-requests are, if you use $request URI, which is basically the whole path after the domain name, sub-request Nginx uses in request URI, it uses the original request. So if you would use that key for sub-requests, you would override your cache all the time. And then we set the fastDJ cache key to that. My magic script. And I put it under siege. Just a note, I have the system twice there. I have the TYPO3 is installed twice. Once configured with the extension and once not configured with the extension. So not just that I changed the configuration of the Nginx right now, I changed the document root as well. So I have a TYPO3 with the extension installed, so I don't have to do compose install right now. And there we go. Service under siege. We still use the prefetch and the log feature, and we still have the web page here. Let's look how the load is. The load will be a bit worse because we do for one request on the, for example, on the start page, we will have 3 sub-requests because I know there's 3 uncached objects on the start page, for example. So the load will be a bit higher. We will have a bit less throughput, but we actually have a more responsive website. I can show that here. You see the news part on the right side. On the right side, yeah. I will put one of those news offline. I'm still running? No, I'm not running. And my server is still under 100% yet. And I should use list. Okay, I'll offline the first news. reload the page, and it should be 2 news. So the page, you saw it from the speed that this page just loaded. It was cached. The whole the whole normal start page was cached, and it just reloaded the news part. Otherwise, it would be much slower. Okay. So now we have a setup which allows us to prefetch content, cache them based on their lifetime. Engines will use the cache control headers for determining the lifetime of the cache content. And we have non-cached objects still there, and they still work. And there are no, I can show that as well. Network. So you see, there's no trickery, there's nothing else loaded via Ajax or something. It's just a document. Of course, to show that, to prove that, I have to actually add the Ajax, but you see, it's just one document. There's only one document loaded, and the dynamic parts are included via server-side includes. Advantages of that part, as I just said, the cache control headers are recognized. They are honored by Nginx. They are given to the browser finally. Did you know when you have uncached content in your web page without any other hijinks, you will never get a last modified date from TYPO3. It will always tell the browser it's not to be cached this page if there's a single user int object in there, or a COA int. It will not be cached, unless you do extra stuff to that. Uncached content will still be delivered directly. You can have your shopping cart or your news, if they're so important, and only the surrounding parts will be cached. So we effectively have it compartmentalized based on their lifetimes. Extensions, the non-cached extensions can now send their own cache control headers, which will be recognized by Nginx and will be invalidated based on those cache control headers. So if you have a useInt extension now, it will be able for you to send inside the extension, because only the extension runs now, to actually control the caching. That means as well, extension can make better use of the TYPO3 cache. And it's less work for the PHP process right now. We can as well separate the whole PHP render into several processes. It won't run in one process, it will run in several processes because we have several requests now, which will utilize your 16-core machine as well better, or 64-core, whatever your fancy is. And finally, multiple uncached extensions in a single page can be handled separately. Nope. Other cool stuff you can do with that. This Nginx cache could be stored in a Redis cache, and which would enable a failover server immediately use the cache. If you don't do that, if you only have a local cache or don't have a cache at all, a failover server would hit, the main server will go down, and the failover server would boot up, and it will hit the backend, the PHP backend, with full force, and probably knock out the PHP backend just because I mean, what's the purpose of the failover server? Not to knock out the PHP backend or the website. So what you do? You can use a Redis cache, and you will have the failover server will have a ready-to-use cache. Or you can have multiple front-end servers, multiple engines which use the same cache. So only one of them is actually using creating a cache, and all others can benefit from it. Nginx has 3 interfaces to talk to other services. One is the fastCGI interface, next is the WSGI interface, and the proxy interface, which is a pure HTTP interface. Everything I showed you can be done with the proxy interface as well, with pure HTTP calls. For example, if you have a Docker-based backend, you can put that Nginx in front. Or if you have an Apache-based backend running in port 8080, you can use this part and just put Nginx in front and use the advantages and have your flexibility with Apache, if you like that. And the SSI technology, as old as it is, you can actually use it to pull in content from other stuff, like a Python application or a Ruby application, if you want, or a Node.js application, which can just render a part, like a widget of your web page. This can be put in there without any further changes. You guys just have to add the markup if you want to do that. That was the main part of my talk. Questions, discussions? Thank you very much. I can show just a short thing. I can show you why I didn't use 1500 concurrent connections. Because we're getting kernel limits now. We're at the kernel limits, we would have to open more file descriptors, more target descriptors and everything. So that's the reason why I didn't show the 1500. I tuned it once before my card gave up here on Sunday, and I had to reinstall the whole thing. I had the kernel tuned. I managed 1700 concurrent connections. I think then the network interface on that little thing is on its limit. Thank you. I'll be here the whole weekend. Whole week, almost whole weekend, until Sunday. Thank you.
Thank you very much, Frank. Now, does anyone have any questions? We would give you the microphone, and you can ask them, and Frank can answer them. No questions. All right. Then I'll ask you to vote this talk with those pieces of paper. There'll be a bowl in the back. Just toss them in there, and I'll send you guys all off to coffee break. See you. Bye.